Hey, looking at the 2013 AB free response question number 4. This is a non-calculator question. And the calculator is really not going to be a huge help anyway because we don't have an equation for this graph. We just have to go off the numbers they give you. So we are given the graph of f prime. Always pay attention to what the graph represents. They do tell you f is twice differentiable, so all theorems are fair play. They tell you that the horizontal tangents are at 1, 3, and 5. Which you probably would have assumed anyway, but those are horizontal tangents. The areas of the regions are given, and they tell you that f of 8 is 4. There's an initial condition that may come into play. Okay, so find all values on which the function has a local minimum, and a local minimum, your thought process should be that f prime changes from negative to positive at a critical number. Must be a critical number. And so that's at a critical number. Okay, so that's your game plan. A local minimum, that should be your first thought. You can use the second derivative to justify a local minimum. However, the first derivative test is your most commonly used approach. And so first thing I'm going to do is find the critical numbers. So I want to first show where does f prime equals 0. And f prime, we are looking at f prime equals 0 at x equals 1, x equals 2, 3, 4, and x equals 6. Okay, so I've established my candidates, and to find a local minimum, we need the one that shows where the derivative changes from negative to positive. And remember, we are looking at the derivative. So at 1, the derivative is above the axis on both sides. That would be nothing. Your derivative is positive, then remains positive. So 1 is out. 4, actually, I'm not going to mark it out. At 4, my derivative is positive and then negative. 4 is a maximum. The derivative was positive before 4 and negative after. And then at 6, there is your local minimum because the derivative is below the x-axis, then above the x-axis. That makes it a local minimum. So local min at x equals 6 only because f prime of 6 is 0. It's a critical number. And f prime changes from negative to positive at x equals 6. So there is your explanation. And a lot of times the justification, you kind of know what the justification is going to be before you even start the problem because so many justifications have the same approach. A local min or a max, you're going to show the derivative changes signs. If they ask for concave up, you want to show that the second derivative is positive, something along those lines. So justification a lot of times is fairly straightforward. Let's go on to part B. Determine the absolute minimum. Okay, now that's different. Absolute, you have to consider endpoints also. We're going from 0 to 8. Okay, so my absolute minimum, so my candidates, you want to list the candidates first. Sometimes they give you points just for listing your candidates. And an absolute minimum can occur at the endpoints, which is x equals 0 and 8. They can occur at critical numbers also. And even though I did this in part A, I'm going to write it again. F prime is equal to 0 at x equals 1, 4, and 6. Okay. Now, as far as the critical number candidates, if you want an absolute minimum, your critical number would need to be a local minimum. So anything that is not a local minimum, I would go ahead and throw out. And 1 and 4, we already established in part A, are not local minimum. So x equals 1 and 4 are not local minima. And since they are not local minima, there's no way they could be the absolute minimum. And so we really only have 3 candidates. We have x equals 0, 6, and 8. And then with absolute extrema, usually what you'll do, and there are some exceptions, this is not one of the exceptions, but usually what you'll do is you will attempt to find the values of the function at each of those candidates, f of 0, f of 6, and f of 8. And we know that f of 8 is 4, I'm going to look for the one that returns the lowest value because it does specify to find the absolute minimum value. That means the actual y-coordinate, the output when you plug in the candidate. And so to find f of 0 and f of 6, because I have an initial condition of f of 8, I can figure those out by saying, well, f of 0 would be f of 8. I have an initial condition plus I'm given the derivative. We're going to measure the change in the derivative. Now, here's where you have to be careful. They gave us the far right endpoint. We will need to go from right to left. So f of 8 plus 8 to 0, and then f of 6 is going to be f of 8 plus the integral from 8 to 6 of f prime. And these are going to be fairly easy antiderivatives to evaluate because they are measures of area, and they gave you the areas right here. We have an area of 2, then 6, then 3, then 7. And so f of 8 was 4 plus. Now for the area, be careful because we are traveling from right to left, which is a negative direction. So when I add up these areas to get all the way to 0, yes, this is an area of 7, but going from right to left, that would be a negative 7. This area of 3 is below the x-axis, which you typically think of as a negative area. However, I'm going from right to left, so that would be minus the negative 3, or plus 3. And then that area of 6 would be a negative 6. That area of 2 would be a negative 2 because I'm going from right to left. And then when we evaluate that, we get 4. Negative 7 plus 3 is negative 4, negative 12. So it'll be 4 minus 12. That's a value of negative 8. And then we'll do the same thing at 6. So that's going to be 4 plus, and then that integral from 8 to 6, right to left, that area is going to be negative 7. And so that would be a value of negative 3. And we are looking for the absolute minimum. And so the absolute minimum would be negative 8. The absolute minimum is negative 8 on the interval 0 to 8. It does say justify your answer. In an extreme value theorem case, the justification is the consideration of your candidates, your endpoints, your critical numbers, and showing how you evaluated it. So this is one of those cases where your work shown is the justification. And do remember that you are looking for the minimum value. Notice I did not say the absolute minimum is at x equals 0. I gave you the value that was returned. If they want the x coordinate for an absolute minimum, they will ask you specifically at what x coordinate does the minimum occur. And they didn't say that. They wanted the actual value. So let's move on to part C. Find the open intervals in which the graph is both concave down and increasing. Okay, the increasing part is going to be the easier part because if something is increasing, the derivative needs to be positive, and I'm staring at the derivative. And so my derivative is positive from 0, and we have a brief instant of the derivative being 0 at 1, but it is okay, but since the derivative is positive on both sides, I'm going to say f is increasing on the interval 0 to all the way to 4, and then again from 5 to from 6 to 8, because f prime is positive. Okay, so there's the increasing part. Now for the concavity part, concave down, we generally think f double prime is less than 0. However, I don't have f double prime. I'm given the graph of f prime, so I actually have to connect my concavity to f prime instead of f double prime. So if f double prime is negative, that would mean, so if any derivative is negative, that means its antiderivative, the original, is decreasing. And so f double prime being negative means that f prime is decreasing. And so I'm going to look for the intervals where this derivative is decreasing. And this derivative decreases from 0 to 1, from 3 to 5, and that's it. And that's because f prime is decreasing. And if you want to connect it to the second derivative, that's fine. Do make sure you write because f prime is decreasing because we are looking at f prime. Don't simply say f double prime is negative because you had to do some thought process. You had to have some interpretation of f prime to make that conclusion. But if you want to say f prime is decreasing, therefore f double prime is negative, you can do that. But you must write down the f prime decreasing part. So now the conclusion, therefore, f is increasing and concave down at the intersection of these intervals. So that would be from 0 to 1. So 0 to 1, and then it looks like from 3 to 4. And you could actually go back to the graph. We're looking for where this is positive and decreasing. This is positive and decreasing right here. Positive and decreasing from 3 to 4 as well. So if you want to look at the graph, you can find it on the graph, or you can just in your mind find the intersection of these intervals. And so 3 to 4, and we've already kind of justified it. It says just explain your reasoning. I kind of did the explanation in the front end, and then I found my conclusion at the end. So that gets me to part D. They introduce a function g, and they tell you that f of 3 is negative 5 halves. Find the slope of the line tangent to g at x equals 3. In other words, find g prime of 3. And because I don't have a function, well, it's not a calculator problem anyway. I was considering the derivative at a point command, but this is a non-calculator problem anyway. We will have to write down g prime in terms of x, which will be a chain rule. We're going to bring that 3 down. F of x squared times f prime of x, and then we will plug in 3. So g prime of 3 is 3 times f of 3 squared f prime of 3. F of 3 is negative 5 halves squared. And f prime of 3, we are given the graph of f prime here, and f prime of 3 is 4, so it'll be that times 4. I would stop there. I would not go any further. There is no reason to clean it up any further. It does not ask you to interpret this answer. We don't have to do anything with it. It just said find the slope. That is the slope. So on the AP exam, please stop here. However, for those of you who did choose to simplify this further, I'm going to do that just so you can see what the final answer is. So that'd be 3 times negative 5 over 2 squared is 25 over 2. No, it's not. See, there's why you don't do this. I just made a mistake. That's the kind of thing that can cost you points. It's 25 over 4. 25 over 4, that's times 4. You can cancel those 4s, and 3 times 25 is 75. So you get a final answer of 75, but there is absolutely no reason for you to do that. You can only take your correct answer and make it wrong. You will not get more points for simplifying, and that is all of this problem from, was it 2013? I think so. Yes, this is all of the 2013.